All right, so we are going to do a lecture on how to calculate t-test using Excel rather than pen and paper. And Excel will automatically calculate it for you, but I won't show you that right now. You have to have the stats package included in your Excel. I forget where it is. I haven't used it. It's been a long time since I've used it. So yeah, but it's probably somewhere in this tab. I'm not positive. Formulas maybe, because it does a whole bunch of stuff. Excel is very cool if you're into that kind of thing. All right, so let's get rolling here, and I'm going to pull over the formula sheet. Just we'll go back and forth with the formula sheet here to reference it. And so every now and again. So pull this up. So pause the video if you can and pull this up. And we're going to work from this and the Excel sheet. I think it'll help you to go through this method as well, just to be able to use the sheet. Okay, so I'm going to put it off to the side for now, but I'll be referring to it off screen. All right, so this first part. So I've dropped in a set of numbers here, and these are x, right? Oopsie. Set of numbers right here. This is x. Okay, and in x, you have 1, 2, 3, 4, 5, 6, 7, 8 numbers. So the sample size is 8. So n equals 8 over here. Total n then is 16. And equals 8 over here as well. And so we'll be using this later. So the degrees of freedom is what? 8 plus 8 minus 2. So it's 16. No, it's 14. All right, so anyways, here we go. So let's look at, this is x. We have our 8 numbers here. Group 1, aka the mean 1 or M1 or mu1. And then over here, group 2. So the first thing we're going to do is set up the square of x. So x squared right here, x squared. All right, so I'm going to type a formula in. I'm going to push equal. Equal signifies to Excel that it's time to do a formula. And then I'm going to click right here on B5, click on B5. Then I'm going to enter a multiplication sign, which is the asterisk in this. I'm going to click B5 again and hit return, and we should get 144. Ah, that's good. All right. What you can do, if you see this little greeny cube here in the corner, you can click on that and drop it down, and you should get 121. Ta-da! It works. All right, and then you can do it all the way down. It's quite quick. All right. So now we just did that. I'm going to do it over here. I'm going to do them just both at the same time. Hit equal sign, 13, multiplied by itself. I'm going to click J5 again, hit return, and drop it down. All right, so we now have x, and we have x squared on both groups, n of 8. Okay, so the next thing I want to do is, so let's consult the formula and bring it over so you can see where we are in this. All right, so here we are with the formula. I've set it up so that I can now start working to find SDM, the standard error of the difference between the groups. And so I'm going to calculate here in step 1, calculate sum of squares for samples 1 and 2. And I'm going to use the same formula for both. I need to get sum of x squared and sum of x. So I'm going to copy this so we can refer to it on the Excel sheet. And let's move this off screen again. Okay, so I'm going to just put it down here so we can look at it. And there it is. It's not beautiful, but it works. Okay, let's make it a little bigger. All right, so now we can see it here. So I need to get 2 terms. I already know n. N for this is 8. So I'm looking to get the sum of squares, not the sum of squared deviations, the sum of the squared scores. Okay. Sorry. I mean, it's this. In this case, I'm looking at the sum of the squared scores, which is this and this. This is the equivalent of sum of squared deviations in the old formula. Hope I didn't just confuse you then. If so, come to the drop-in session and we'll clarify. All right, so I'm going to first add up all of these. Okay, so I'm going to get sum of x, which is up here, right? The parentheses means everything. Sum of x. So in this case, when I'm looking at this term, you sum first square second. Sum first square second. With this one, you square first sum second. Square first sum second. All right. Sum of x. We already know sum of x. It's listed at the bottom here as 80. And we also have our mean of 10. So I'm going to write that in too, because I'll need that later. Mean of 10, which means these must add up to 80, because there's 8 scores divided by, that's right, so 80. So the mean, so sigma x, so this term here, sigma x, and I don't have a really nice way to quickly write it, so I will just put sigma x. So what is sigma x? It's 80. Actually, let's do this. Let's do the mean here, 10. I'm just transferring over. N is 8. That way, you can see we're just sort of doing this as we go. And here's this. All right. So that's pretty. We'll do that on the other side. Copy, paste. And here we go. So we have these. So now we have sigma x, so or the sum of x. Sum first square second. All right, so we're going to sum it, and now we're going to do sigma x squared for this one. And so you multiply this 80. We'll do a calculation. 80 times itself, and it gets you 6,400. All right, so the term up here is going to be 6,400. All right, you with me? Now, we have this term. We just need this one and we're done. So, and this is pretty easy. All we do is the sigma of x squared. So you square first, sum second. And the answer there is 844. All right, so that will be its own little doodad. We'll call it sum of x squared, just to differentiate it. I don't know if that's helpful. Maybe it is. All right, so now sum of x squared, you sum this right here. Click on your little auto sum feature, boom, 844. All right, now let's plug these in. So let's do this equation first. I'm going to do, okay, so let me walk you through this. 844 goes here. 6,400 goes here. And 8 goes here. So the first thing I'm going to do is, I'm going to just do this in Excel here. So I'm going to take an equal sign, and I'm going to first take this number, 6,400, divided by the n, and now it's 800. Okay, so I have 800 right here. All right, so now I know 844, which goes here, minus 800 is 44. So sum of squares for group 1 is 44. All right, if you're not sure what I did, let's do it again. So I'm looking at sigma x, quantity squared. Okay, this is this. Sigma x, quantity is 80. 80 squared is 6,400. So this term right here is 6,400 divided by 8 is 800. Okay. Now, I'm going to take this 844 and put it here. 844 minus 800 is 44. So I'm just going to write it down here. That's SS1, and I'm going to bold it just so I remember what to use it again. All right. Going to do the same thing over here. Let's do it again. So we already now have the sum of squares. Let's pull this back over. Okay. So we have the sum of squares for this. It goes right here. All right. Now we're going to get this one. The second sum of squares from group 2. And we already have this number. We have all the other numbers. What we don't have yet is this, sum of squared 2. So let me pull it back over off the screen again and back to this. And we're going to do the same thing. Let me move this over here so we can look at it. All right. So first thing I'm going to do is put the n in. Why not? Let's do that. Actually, let me move this over one just to make it look a little more uniform like the others. So we have 8 of these, so I'm going to put n of 8. Then I'm going to take the average. I mean, it just automatically calculates it, so it's 10.75. So put that in, 0.75. Sigma x is right here. Sigma x is 86. Okay. Now I'm going to do sigma x squared. So say it out with me. I'm going to put in the formula equals, multiply 86 by itself. Whoops. I'm multiplying 86 by itself by just clicking on the tab that 86 is in, hitting return. And I have 7396. Okay, so 7396 is going to go here. Then I've already done the squares of x. So the sum of squared x is 972. And we put that... put sum of x squared right here. All right, so now we have the sum here of x squared as 972. And we got our two terms. All right, so always the bigger number is going to be on the top over here, So it's going to be in the fraction. So the bigger number will always be to the right. The smaller number will always be to the left. All right, so let's go ahead and calculate it. So I'm going to first calculate this part, which is, I'm going to just use the formula to do that. Okay, 7396 divided by the sample size, which is 8. I got 924. So I'm now going to take this 972, which goes here, subtract it from 924, and I am going to do a formula just so I don't goof my math up. Click that, subtract it, hit return, 47.5. So SS2 right here is 47.5. All right, so now we have those two numbers. So let's go over, and this is probably easier to do by hand, but we'll still do it in Excel. You can do it by hand if you want. We want this equation now. All right, let's move this back off the screen. Off you go. All right, so now I'm going to just scroll down a little bit. All right, let's put this here. So you can see it, get rid of this one. All right, so we're going to work with this now. All right, so here's what we have. We have SS1 and SS2, N1, N2, we have M1, M2, and we will, let me just do it in Excel. This might get a little messy, but bear with me. So the first thing we're going to do is I'm just going to calculate this out over here. So 1 divided by N, 8. 1 divided by 8 is what? What is that? 0.1275? Let me look. So we'll do it. 1 equals 1 divided by 8, 0.125. Yep. Okay, so 0.125 is going to be here, plus 0.125 is 0.25, right? So let's see. Equal this plus, just so I don't make any mistakes here. Yeah, 0.25. Okay, so 0.25 goes right here. So we will put that in bold. Like I said, it's going to get a little messy. So 0.25 is for this term here. All right, let's do this. Now we'll do it over here. So the first thing I'm going to do is add sum of squares for group 1 and sum of squares for group 2. And here it is. 44 plus 47.5 is 91.5, right? So 91.5, just going to put that here so I don't forget it. 91.5. And then divided by, it's going to be divided by 14. And this is the degree of freedom term. N1 plus N2 minus 2. Okay, so 91.5 here divided by, so we'll do an equation, 91.5 divided by 14 is 6.54 with rounding up, 6.54. So now I'm still, so I have this whole deal here is 6.54. This whole deal here is 0.25. I'm going to multiply them together because this parentheses here and this parentheses here, these two together mean multiply. So I'm going to take this number, multiply this by this, and I get nothing. Correct. Okay, let's do it again. What happened here? Okay. Okay, I didn't multiply it. So here we go. Let's try that again. All right, equals this times 0.25, return, there we go. So 1.633 is what goes under this square root sign here. Now we got to take the square root of this, also do equals SQRT, oops, I did not do that correctly. Okay, let's do it again. Equals SQRT, yes, and it should put up the parentheses, there it is, square root of this, and we get 1.278. All right, so this right here is the number for the whole bottom deal. Now we're going to take the mean of, well, we're going to take the larger mean from the smaller mean, and it doesn't matter if with the labels here, whatever the larger mean is, we're going to put it first. So larger mean is 10.75. So 10.75 here, subtract 10 is 0.75. And we'll put that right here just to remember. All right. 0.75 divided by 1.27, we have our t. So let's do that. 0.75 divided by this, and there's our t, 0.586 or 0.59. And that is it. The last part is way inefficient. It's just a lot easier to do it on pen and paper, but if you want to do it with Excel, you can. Probably, you know, the easiest part for Excel is to do the groups and to find these terms. Okay, so hopefully that was helpful for you. So you can use Excel to speed up the process, but this last part wasn't too speedy. But there it is. So t is right here, 0.586. All right, and then that's critical value, and you take that to the t table, and there you have it. All right, we will talk to you soon.